Hello everyone! Today our group is excited to present the Smart Thermo Mailbox. To kick things off, let's address the need behind our innovation. What physics-related concept are we addressing? We are targeting the challenge of thermal degradation in food, especially how cooked food rapidly loses internal energy to its surrounding, leading to a drop in temperature and quality. The specific physics principles involved here belong to the thermal physics, focusing heavily on the laws of thermodynamics and the three mechanisms of heat transfer, which is conduction, convection, and radiation. When hot food is placed in a standard container, heat spontaneously flows from the higher temperature food to the lower temperature environment, following the second law of thermodynamics. Our product addressed the critical need to disrupt this energy transfer to keep food fresh and hot.
Assalamualaikum, my name is Nafisa. So, today I will discuss how does our smart thermo mailbox work based on thermophysics principles. So, our approach utilizes a multi-layer insulation system paired with an active, self-regulating heating element. To combat conduction, the mailbox features a double-wall inner container with a partial vacuum layer. Because conduction requires a physical medium to transfer kinetic energy between particles, the vacuum effectively minimizes this loss. To address convection, the lid uses airtight silicone seals that prevent hot air current from escaping. Okay. So finally, to stop radiation, the interior walls are lined with a high zero reflective, low emissivity aluminum coating that reflects infrared radiation right back into the food. For active heating, we have integrated a PTC, which is positive temperature coefficient heating element powered by a compact battery, which safely adds thermal energy whenever the internal sensors detect a temperature drop.
So, how does our smart thermo mailbox work based on thermophysics principle? Our approach utilizes a multi-layer insulation system paired with an active self-regulating heating element. To combat conduction, the mailbox features a double-wall inner container with a partial vacuum layer. Because conduction requires a physical medium to transfer kinetic energy between particles, the vacuum effectively minimizes this loss. To address convection, the lid uses airtight silicone seals that prevent hot air current from escaping. Finally, to stop radiation, the interior walls are lined with a highly reflective, low emissivity aluminum coating that reflects infrared radiation right back into the food. For active heating, we have an integrated PTC, which is positive temperature coefficient heating element powered by a compact battery, which safely adds thermal energy whenever the internal sensors detect a temperature drops. The exact physical process and equation involved, we look at Fourier's law of thermal conduction and the specific heat capacity formula, which is Q equals to MC delta T, where Q is the thermal energy required, M is the mass of the food, and C is its specific heat capacity, while delta T is the change in temperature. Our active heating elements use electrical power to generate heat to counteract the natural thermal loss calculated by Newton's law of cooling. What outcomes can be observed from this system? Visibly, users will see a digital LED screen displaying a rock-steady optimal temperature of 65 degrees Celsius. Physically, the internal shell of the box remains cool to the touch due to the high thermal resistance, while the food inside remains perfectly hot, fresh, and steam intact for hours. Our approach successfully manipulates thermal physics to deliver a smarter, safer dining experience. Thank you. Now, let's look at the benefits of our smart mailbox. First, it keeps food warm from several hours. Second, it saves time because users do not need to reheat their food often. Third, it is energy efficient because it uses less electricity. It is also portable, so it is easy to carry anywhere. Finally, it is suitable for students and workers who want to enjoy warm food anytime.
To conclude, our smart thermal mailbox is more than just a convenient lunchbox. It is a practical application of core thermophysics principles engineered for everyday life. By directly addressing the natural problem of heat transfer, our design successfully tackles the real-world need for food safety and quality. Through our approach of combining the advanced vacuum insulation, reflective radiation barriers, and an active PTC heating system, we have created a solution that minimizes thermal energy loss and maintains an optimal temperature effortlessly. We have taken complex physics concepts from heat transfer mechanisms to thermal equations and turned them